So in 7.3 we talk about the sine and cosine function, and you've seen sine and cosine before in right triangles, and we're using the same general principles that you've seen sine and cosine before when you talked about the right triangles, but we're going to start throwing them into our circles that we've been looking at. So think back to when you learned about sine and cosine for the first time. You looked at SOHCAHTOA to learn how to memorize sine and cosine. So what all that means is that the sine of theta, and theta is the angle, so here we'll put theta right in here, is the opposite side, so the side across from the angle, over the hypotenuse, which is always the side across from the right angle. Cosine is the adjacent side, adjacent means next to the angle, over the hypotenuse, and tangent is opposite of or adjacent. Again, we're going to use SOHCAHTOA, but we're going to start putting this into the coordinate plane. So here's what that triangle would look like inside of the circle. We've already talked a lot about how we want our angle always to be here, our central angle, and be on the positive x-axis. So we're going to put theta in here. Now, if we take that same triangle we just looked at, the opposite side will always be y. The adjacent side is always going to be x. And our hypotenuse is r. So our hypotenuse is always going to be a positive number. So when we look at sine, if sine is opposite over hypotenuse, the opposite side here is represented by the y value, and the hypotenuse is always going to be the radius of my circle. So a new way of thinking about sine is y over r, and we're going to use this a lot. Whereas cosine is adjacent over hypotenuse, so the adjacent side here is x, the hypotenuse is r, so sine is always going to be x over r. So notice that they're always over r, and we have to remember which one goes with x and y. Just a quick little thing that I always thought of, cosine and sine, if we write them out alphabetically, cosine obviously is c, comes before s in the alphabet, x comes before y in the alphabet, so x goes with the cosine, y goes with the sine. So here we're trying to find sine and cosine that go through a point for -6. So the first thing I always do every single time I have a problem like this is I actually draw out what that would look like. So we have a coordinate plane, it goes through the point 4, oops, my apologies, +4, -6. So the point's down here. So if we think about our unit circle when we do this, so it'll look something like this. Here's our triangle. Always goes out for the center, like we talked about before, and then up to the x-axis. So our triangles are always going to be on the x-axis. There's our triangle we're looking at. So if you think about it, this x value is this side of the triangle. This is the y value, so it's the height of the triangle. Now what I need to find is the radius of the circle. Well, that's really easy to find because what I have here is a right triangle. So I know that 4 squared plus -6 squared is equal to r squared. So 16 plus 36 is equal to r squared. Therefore, r squared is equal to 52. So r is the square root of 52. 2 is equal to r. So now that I have r, I know that sine is y over r. So my sine value here will be -6 over the square root of 52, which we can simplify, and we'll do that in a second. And the cosine is x over r, so it's going to be 4 over the square root of 52. Now we can simplify this. The square root of 52, the square root of 52 can be written as the square root of 4 times the square root of 13, so it's really 2 root 13. So I can rewrite this as -6 over 2 root 13, which can be reduced to -3 over root 13. Now you may remember we don't like leaving radicals in the denominator, so I'm going to multiply the top and the bottom by the square root of 13. And we get -3 root 13 over 13. That's the answer for sine. And for cosine, we're going to do the same thing. So we have 4 over 2 root 13. 2 and the 4 can be canceled. Multiply top and bottom by square root of 13, and I get 2 root 13 over the square root of 13. So there's your sine, there's your cosine. Let's do one more problem similar to this, what we just did, but the question just asked slightly differently. So here it's asking us to find cosine if sine of theta is 3/7 and it lies in the second quadrant. So I know that my angle's in the second quadrant, which means it's going to be over here. And again, I'm going to draw my triangle. Anytime I draw a triangle, one of the sides of my triangle has to be on the x-axis. So this is what my triangle looks like. Okay, so we have that. Theta's here. And it says sine is 3/7. So since sine is equal to 3/7 and sine is y/r, I know my y value and I know my r value. My y value is 3. That's a vertical distance, so 3. My r is 7. Now I can easily figure out what my x value is by, again, using Pythagorean theorem. So we have 3 squared plus x squared equals 7 squared. So 9 plus x squared equals 49. Subtract 9 from both sides. X squared is equal to 40. So x is equal to the square root of 40, which simplifies down to 2 root 10. So here my x value is 2 root 10. But this is one of the really important reasons why we draw out a diagram. Notice that it's in the second quadrant, and every time we're in the second quadrant, my x values are negative because I'm going to the left. So here, this x value is actually negative 2 root 10. So now when I write the cosine, it's negative 2 root 10 over 7. So what we want to do here is find the sine and cosine of 12,5 and negative 12,5. So again, my triangles are always drawn to the x-axis. So one of my sides of my triangle is always on the x-axis. So here's my triangle. My y is 5. My x is 12. And maybe you remember the special right triangle, 5, 12, 13 is my radius. So in this one, we have that the sine of theta is y/r, so 5/13. And the cosine of theta is equal to 12/13. Let's do it for our other triangle. So here, or our other angle, is our new theta. But notice we always want to draw our triangle to the x-axis. So since this is true, what's going to be true about these two triangles? Well, they have the same properties because my x value is negative 12, my y value is positive 5. The only thing really different in these two triangles, my radius is going to be the same, 13, is that my x value is negative instead of positive. So my sine value actually stays exactly the same, 5/13, but my cosine value, because it talks about x and now I'm in the second quadrant, is negative 12/13. And this is why we start talking about families of angles, because even though the triangles are in different quadrants, it's the same triangle, just kind of flipped into different quadrants. So it's just going to make my sines and cosines either positive or negative depending on where they are. What I would like you to do now is try to pause this video and see if you can find the answers to these, that if sine is 15/17, find cosine of theta. And this is telling you that theta is in the second quadrant. That's a really important piece of information. So make sure you draw your triangle, figure out the information you need, find cosine. Do the same thing with the next one. Find the sine if this is cosine and it's in the third quadrant angle. When you press play on this in a couple seconds, I'll give you the solutions. So the solution for the first one, if you do this correctly and you make a second quadrant triangle, it gives me sine, so I know that this is 15, this is 17. When you work through your special right triangles, you get that this side is 8. Again, since I'm going to the left, it's negative 8. Therefore, the cosine is negative 8/17. For the second one, I have to make my triangle in the third quadrant. Again, always making one of my sides part of the x-axis. So cosine gives me x, negative 7. And over the radius is 25. Use your special right triangles or use the Pythagorean theorem to get a 24 here. Since we're going down, it's negative 24. Therefore, the sine of theta is negative 24/25. what's going to make our life really easy is when we start talking about the unit circle. And the reason why it's called the unit circle is because the radius will always be 1. And what we're going to do is take this triangle with a hypotenuse of 1, or if you think of the unit circle, which you guys are going to do your project on, here you're going to have all of these triangles, and in every single one of the triangles, the radius is 1 because it's part of the unit circle. So now when we go to talk about sine and cosine, put it as part of your unit circle this way. Here's in my first quadrant. Remember, this is y, this is x. Cosine, we usually talk about cosine of theta is x over r, but in the unit circle, again, it's only true if we're talking about the unit circle, cosine of theta is just the x value. This is only true when the radius is 1. And therefore, when we talk about the sine of theta, usually we say sine of theta is y over r. Here, in a unit circle, r is 1, so sine of theta is really just equal to the y value. So here's what's important for you to know for today, and then tomorrow we could talk about some other important things, is that because this is a unit circle and my radius is 1, this ordered pair will be 1, 0. This ordered pair is 0, 1. And then we have negative 1, 0, and 0, negative 1. Because we know this, there's a lot we can now tell about sine and cosine. Since this is a unit circle, x cosine of theta is equal to x, so whatever the x value of my ordered pair is the cosine at that angle. Whatever the y value is at my ordered pair, that's the sine of that angle. So if I'm looking for the sine of 90 degrees, all I need to do is go to my 90-degree angle, which is up here, and look at the y value. It's 1, so the sine of 90 degrees is just equal to 1. The cosine of 90 degrees is going to be equal to 0 because the x value has to do with cosine, and the x value of cosine of 90 degrees is 0. We could keep going. We could ask for the sine of 180 degrees. Well, that's looking for the y value at 180 degrees, which is 0. And then for the cosine of 180 degrees, that would be equal to negative 1. So by using this unit circle, we could figure out a lot of exact values for our sine and cosine functions. This is the last slide that I really want to look at today. What if we're looking to find the value of each one of these expressions? So here, if I'm looking for the sine of negative 180, we all know by now that negative 180 is here. So what I'm really looking for is if this is a unit circle, again, my radius is 1, what's this ordered pair? Well, since my radius is 1, I'm going to the left. It's negative 1, 0. Sine has to do with y. The y value there is 0, so the sine of 180 degrees is 0. We could keep going. Cosine of 3 pi over 2. 3 pi over 2, if you remember, is down here. Since we're at cosine, 0, negative 1, cosine has to do with my x value. The x value down here is 0, so that answer is 0. Cosine of 4 pi. 4 pi, all I'm doing is going around 2 full times, and then I'm ending up here. So what's my ordered pair there? 1, 0. Cosine has to do with the x value. The x value there is 1, so we have 1. And we could keep doing this for these what we call quadrantal angles, angles that end up on one of my axes. Tomorrow when I'm back in school, we're going to go over the specific families of functions that we've been talking a lot about.